that into my view. Right, so in this case, I'm going to say, this is example B, and let's say Larry is 5 centimeters shorter than Bob. And we'll throw in another guy. Let's say Mike is 170 centimeters tall. And twice Bob's height is 3 centimeters more than the combined heights of Mike and Larry. Period. What is Bob's height? So let's say we know that B is Bob's height. M is Mike's height. And that would be equal to 1/70, which will make this problem a little easier if we look at it that way. And we also know that Larry's height is L. L is Larry's height. So we're basically looking at L and B as our two variables. Even though Mike has a height in there and there's another person, we know his height already, so we can use that as a number rather than a variable. So we're going to try to relate B and L together using the information given to us. Larry is 5 centimeters shorter than Bob. So Larry is shorter than Bob. Larry is shorter than Bob, so if he's shorter and you want to be equal and get the same height, you have to add height to him. So you have to add 5 centimeters. Okay, so Larry plus 5 centimeters would give you Bob's height. That's our first equation. Our second equation is going to come from the next step here. It says twice Bob's height is 3 more than the combined heights. Okay, so twice Bob's height is 3 more than the combined heights. So it's going to be, in order to make them equal, we have to remove 3 from that. And that's going to be the combined heights of Mike and Larry. So Larry's L and Mike is 170. Now you might be asking yourself, well, why are we putting a subtraction sign here? Well, when it says more. But if you read carefully, it says twice Bob's height is 3 centimeters more than the combined heights of Mike and Larry. So the combined heights of Mike and Larry are going to be twice Bob's height, but he's going to be 3 more than that. So twice, that's going to be 3 more than that. So to make it equal, we have to remove those 3 more to get that equal statement. So there's our two equations. So now I'm just going to use substitution because we know what B is. So substitute in for B. B is L plus 5. 2 times L plus 5 minus 3 is going to equal L plus 170 centimeters. And I'm going to leave out the centimeters because we know it's in centimeters for height. So 2L plus 10 minus 3 is equal to L plus 170. So working this out, I'm going to subtract L from both sides. So L, and I'm going to take the 10 and minus 3 from it, plus 7 is equal to 170. So subtract from both sides here, 7. To get Larry's height is going to be equal to 163 centimeters. But we want Bob's height, so let's calculate Bob's height. Bob's height is equal to 163 centimeters plus 5. So centimeters, which is equal to 168 centimeters. So we know that Bob's height is that. So let's do our check and then write our answer. So I'm going to check using the bottom equation because we'll do that, or well, we can check using the top equation. Well, let's use the bottom because we use this equation to get Bob's height. So 2 times 168. Okay, so I'm going at minus 3 is equal to Larry's height, 163 plus 170. So let me just check the field of view, make sure that's still in there, because I think I'm getting close to the bottom. I'll slide it up a bit. Okay, so this would be 2 times 168. So that would be, well, let's get out a quick calculator here, or work it out in our heads if we can. No, well, no calculator, we'll just have to work on it. So that'd be 200, 320, and 16 would be 336. And this would be for adding together here. Okay, we get 200 and then we get 130, so that would be 333. So 333 is equal to 333. So we can now say that Bob is 168 centimeters tall. And that's our example for our second question, dealing with some heights and a little bit of more complex language than the first example that we did. Okay, well, we're going to look at now our third example. I'm going to look specifically here at an example that would deal with speeds and distances. One of those ever popular ones where a vehicle is traveling so fast and it meets this other vehicle, and how fast would each be going, or something like that. So that's the next type of problem that I'm going to deal with. So in order to do those types of problems, you need to know the relationship between speed and distance and time. And keep in your mind that distance is equal to speed times time when we're working on this problem. So I'm just going to center that again before I start the problem.